So good afternoon again. Welcome to the session Leveraging Containers for DevOps. My name is Michael Braam. I'm a senior sales engineer with InterSystems from Germany. Today I have two co-presenters, Ralf Spielmann and Dr. Marko Woelki. I will introduce them to you in a minute. The goal of this session today is to present how awinta leverages container technology and especially InterSystems Iris container to implement their DevOps approach. And what you see today is a real use case, and the implementation is already successfully in production. So we will start with a brief introduction on DevOps, and after that I will hand over to Ralf and Marko. They will present what they did and how it works. And we will have Q&A at the end of our presentation. But if you have questions in between, feel free to ask them. So, what is DevOps? Quick show of hands. How many of you are already using DevOps? Quite a few. How many of you are considering DevOps for the future? Okay. Who has heard about DevOps? Okay. So, what is DevOps? Well, DevOps nowadays is a buzzword. Everywhere you go, you hear DevOps. But DevOps is not a standard or so. DevOps is just a practice to improve the collaboration between the development and your IT operations or your customers. And the goal is to improve the process from development to QD, to deployment, to operations. And the advantage is, or this is achieved by automating the process, and containers play an important role in this automation. And the advantages are for your customers, for your users, that they can benefit from changes, bug fixes, enhancements more quickly. And on the other side, for your development team, that they can develop more efficiently by shipping changes faster to the QD. They receive a quicker feedback, so they have to do less redo work. And so both parties benefit from this DevOps approach. And at that point, I would like to hand over to Ralf and Marko. They will present how they implemented with InterSystems Iris container their CI/CD chain. Ralf Spielmann is chapter manager for database development at awinta, and Marko is database developer. So please welcome Ralf and Marko.
Thank you. Now let's start. When I heard and read about Docker containers first time, maybe 5 years ago or so, I thought, okay, another virtual machine. We use virtual machines for a long time, so we don't need any more of this stuff. So I was wrong. I was totally wrong. I couldn't imagine at the time how much we would need it in the future. So in this session, we would like to tell you something about the advantages for our development using container technology, and what are the benefits for our company and at least for our customers. We will also talk about the reason why we had to change the way of developing and deploying our software. We had been successful for decades, so why change it? Now what we do, one part of our software development is building merchandise management systems for pharmacies. Our new product is called awinta One and runs under the InterSystems Iris data platform. awinta provides fully automated systems for the pharmacist. On the left top, you see our 81 hardware, which is an all-in-one system with scanner module, printer, second screen on the back side, and so on. Now, the simple workflow of the pharmacist, I simplified it down, is putting the prescription from his patient to the scanner. That brings the content to the prescription of the screen, you know all that. Then the picker machine gets a demand to deliver the articles to the point of sale. The patient gets his articles, pays his part of the receipt, selling process is done. Now, when the amount of some articles will fall under a predefined limit, it will automatically be ordered at wholesaler. Okay. When the order arrives, it will be stored back into the picker machine automatically too. So our intention is to free the pharmacist of most routine work so he can use his time fully to advise his patients. Now we have a look of a typical pharmacy infrastructure. We have a client server structure. There is a Linux machine on which InterSystems Iris is installed. And to this machine, the POS workstations are connected by a client connection. The database is not only storing the data, it runs the application itself. The whole application is written in ObjectScript, and the client GUIs are only interacting with the user without doing any logical operation. Let's have a look on our former development. Our former development used to work with the same infrastructure as the pharmacies. We have in the middle one Linux server with InterSystems Iris, to which all developers are connected to. The client developers on the left build and run the applications connected to this machine. The database developers also work together on this one Iris instance. Sometimes at different releases, so this machine is always in an undefined state. At the time, we were a small team of database developers sitting in the same room or at least work door to door. So because we were very close together, communication was easy at any time without problems. And with a bit discipline, sometimes a little bit of luck, the database development works without problems. Times were changing. Now we are part of the Noventi group. Here you see some interesting numbers. All of our subsidiaries have one thing in common. They all operate in the healthcare market. The core target groups include pharmacies, other healthcare providers, care services, doctors, and patients. And you see in the middle we have 2,000 employees, and I say we're around about 120 developers. Now, our company now offers more than one system for pharmacies at the time. These different systems are developed at our 4 locations in Germany and 1 in Romania. Now we're going to merge these systems together to our new future product, awinta 1. Take all the best of old systems and put it together to this awinta 1. This brings us to the comfortable position of getting more developers to work for this new product. But all these developers now have to work together at 5 different locations at the same product, probably at different releases or features. With a number of nearly 8,000 classes at this time, and we grow up, this cannot be done on machines with undefined states as we worked before. Now we had to find a way to make this possible. First, we decided to use Git source control for our ObjectScript code. Now this allows us to work together distributed on common code base. You all know this. Also, we had to move away from the idea of one development server for all developers together. We must have several servers for all the developers in several versioned states. Then we can work for several releases and features, and at the same time at different locations. So we came to think about container technology. Now, what's the benefit of a container? A container is almost a fully functional machine, but without the usual work to set up and configure a conventional real or virtual machine. So you can save a lot of time if you need to create several machines with different version states. Containers are very easy to use and at any location because they're based on an image which will be distributed by the Docker registry. Of course, our Docker containers run the InterSystems Iris data platform. Let's short remember the former situation as seen before. What we had to do. We had to move the central Linux machine to each developer's machine, and this has to run the database in a defined state, meaning a certain release. Now let's have a look on a current developer's machine. Each developer notebook has a hosted Linux machine on which Docker is installed. The infrastructure is virtually the same as that of a pharmacy. We have a Windows client, a POS system, and a Linux server. On this Linux machine, containers are running InterSystems Iris with a version-specific state of our classes and routines. Version-specific, that's it, that's the point. Developers now are able to work for defined releases. If someone wants to do his work for release 230, you see here, he starts this container, and the POS entwickler runs the C# code against this machine. The object script entwickler on our side runs this code. And when he wants to do something for the release to 240, just stop to 230 and start 240. Now every developer at all our locations can work autonomously for defined versions of our state, of our software, all over the world. Using the Git version control, each code flows back into the corresponding release branch. The whole way now, from source code checked into Git, create a new Docker image, and finally push it to the Docker registry, is fully automated with object script running on our build machine. So at any time, our developers or the quality assurance can pull the images, can do their work using a version-accurate container or test it. The usage of Docker command line we have simplified by an administrative web page. This is also hosted in a container with InterSystems Iris, so that not every employee has to use the Docker command line interface. This is our website. You see, you can show what containers are running or what containers you have on your local machine. You can show what images are there or what is going on in the registry, what I can pull down. And you see the button start, stop, delete. It's normal. And there's a small button, it's the yellow button, update. That's not a normal feature for containers, but we needed this. And Marko will tell you more about this. And with this, I will hand over to Marko.
Okay, I would like to give you some technical details on what we did. First of all, what is behind our administrative web page. So we want to run our administrative web page in a container as a microservice, and this brings along some difficulties. Because you see here on this slide before, the list of containers. How do we get the list of containers inside our administrative container? If you are on your Linux machine, you go on the command line and write docker ps and get the list of containers directly. If you are in an Iris instance on your Linux machine, you have access to $ZF and can call docker ps also, and then you get the list of containers. But now we are inside the container. We don't have access to the command line of the Linux machine. Even if we would make a volume mapping, we could copy files to the Linux machine, but we never had access to command line commands. So this is a dilemma we are in, but it can be solved by REST calls. So what we can do is we make a REST call from inside the container to the Linux machine and ask for the containers that are there. So normally you would expect when you make a REST call that we had to define the endpoint of the REST call on the Linux machine, where we state $ZF docker ps, but this is not necessary because we have an API available. The API that is available is called Docker Engine API in a certain version and runs on port 2376. So here I have an example for you, how we get, for example, the list of images. In object script, we create a %net HTTP request object and set the server IP address, for example, 192. And so on. And we set the port number 2376. And then with this object, we make a GET call with a predefined endpoint by this API, version 1.39/images/JSON. And then we get as a response a list of our images. In the same way, we can get the list of containers, of course. If we want to start a container, we want to change something on the Linux machine, so this is not a GET call, but a POST call. Similarly, if we want to stop a container. We can delete a container. This is a delete request. And we can even run a container by specifying the image from which we want to run the container and the name of the container we want to have. And then this code is slightly more involved, but it's also possible. And we can further pull an image by specifying the IP address of the registry server. So this is all of our features that are supported by Docker Engine API. But we further want to know which repositories do we have in our registry and which images can be found under a certain repository, for example. So this is not supported by Docker Engine API. But we have another API available that is called Docker Registry HTTP API that we can use for this reason. And here we can, again, to show the repositories, for example, make a GET call with v2 underline catalog. This is, again, a predefined endpoint, and we get the list of repositories. And if we know the name of a repository, we can call get v2 repository name text list and get the images under this repository. So this is what is behind our administrative web page. Now I want to show you the complete workflow from an initial change in code to a container that contains this new code and which can be run on the machine of any developer. On the left-hand side, you see the Windows 10 machine of a developer, and on the right-hand side, you see the intranet. Inside the Windows 10 machine, we have our hosted Linux machine, and with this, I would like to start. So here we have our different containers running. One container up with awinta 1 release 230, the green one, and one container exited, also with awinta 1 release, but in version 240. Those containers have inside, in certain databases, our classes and routines in the defined state. As you see, the small numbers above the containers, 51773 and 52773, those are the standard ports of InterSystems Iris. And for those ports, both containers are configured. This is the reason why only one of those containers can be run at the same time, and the other one has to be exited because it would occupy the same ports. So since there is a paradigm not to save data inside a container, because a container is not a persistent object and can be deleted quite easily and the data would be gone, we save our data outside by volume mapping. So we have further databases on the hosted Linux machine where we save our data, and we have further the file system available. And you further see the red container. This is our administrative container, which runs on different ports because we want to run it at the same time as our awinta 1 release container, because we might change something inside our container, stop it or run it, so that this is possible. Now we are talking in this picture of object script developer, and this object script developer would connect with either Atelier or Iris Studio to his running awinta 1 release container and write his object script code. Then a process starts in which he pushes his code to Git, in which we build an image that contains the new code and pushing this image to the registry where it can be pulled by any developer. But let's have a closer look at this. If the object script developer has finished his code, he synchronizes, for example, with Atelier, with his local Git repository, and he pushes his branch to the TFS. TFS is Team Foundation Server, a software by Microsoft that we use as a bridge to our global Git repository. But instead of merging the code directly into the global Git repository, we use a concept that is called pull requests. So the developer states a pull request to the TFS and asks for his code to be merged into the global Git repository. Then a few other developers have a look on his code and decide either to merge it or to refuse it. Then a REST call goes from the TFS to our build machine and contains the information if the pull request was successful or not, and if it was successful, under which folder on the build machine we can find the new files. And the new files are brought to the build machine by file transfer into this folder. Then we start building an image that contains this new code. First, we use a base image that contains Linux with InterSystems Iris. And then we run a Docker file and copy the different iris.dat files of our databases into this image. And then we run a container from that image, and we use a method to bring the new files that were pushed to Git into this container. This method I will explain to you in a minute. Then we again persist the container as an image. We use a method to make it smaller so that it doesn't become too large in the registry, and then we are able to push the image to the registry. But we don't do this for every successful pull request, but only once per night. Then, if there exists already an image under the same name in the registry, it is overwritten once per night. And then finally, the developer can pull the image by using the administrative web page and run a container from it, and again can write his code. Let's have a look on the mechanism with which we bring the new files into the container. This is part of our every night build, but it is a method that we can run at any time. As Ralf told you, we have an update button on the web page where if we have a container in a certain version, we are able to update this container with the new files and classes that are in the corresponding folder, and those files can be brought into the container quite easily by this method. But how does this work? We have the hosted Linux machine on the left-hand side, and there you see the administrative container, and below the container 240 that we want to update, for example. Then on the website, we go on container 240 and click update. Then a REST call goes from the administrative container to container 240 and arrives at the endpoint execute update files. This is an endpoint that we wrote ourselves because obviously here we don't have an API available. Then we take the new files from the build machine in gray from update folder 240. And the way we do it is as follows. The method execute update files establishes an SSH connection to the build machine and takes the new files by SFTP. We only take the new files because there are always all those files available that mainly are already inside the container, so we don't always want to copy all those files. So that's the reason why we only take the new ones. And this is done by comparing the file name. Do we already have this file? And if yes, what about the modification date? Is the file newer? Then we take it. And finally, import dir in object script takes these new files and brings them into the database. And this method can be run at any time. So if one developer says, I had a pull request with 3 new classes, and if you want to have them in your container, you can click on Update Container, and the other developer might run this update method and has in his corresponding container the new files inside in a few seconds.
Now let's have a quick outlook. After a certain test period, when all developers, database and client developers, are satisfied with this solution, maybe they find something that we have forgotten and to do this, Also, software quality assurance shall use this technology. I think it's around Christmas time. Then the setup for the Windows clients is placed inside the belonging containers. The container has access to the underlying file system by volume mapping, as Marko said. So in the start process of the container, he copies the setup files, the Windows setup file, to the special shared folder, and the clients know their setup is placed there because in the last years it was on the same place. So they can update the Windows machine with this update. And naturally, we will use container technology at our customers' machines in the future. Now, what are the benefits for all? We have shorter release cycles, and this enables continuous delivery. We have more features in less time because with this technology we can use all our 5 locations and use all developers has time for our awinta 1. Deployment to many thousands of pharmacies, we have in maybe 3 years we have 10,000 pharmacies for this project. We become safer. There is no import of classes and routines any longer so as we do at this time. And a container running on a quality assurance system is running the same way on the customer system too. Add-on software is more easily to deploy only to the customers who have bought this. And downtime while updating a system is very short because the images were already loaded from the registry and the containers are already created. So what we have to do, stop and start, and in 5 seconds I have changed the release. So today's monolithic structure, we will step-by-step change to microservices which can be autonomously deployed at our sites, developed at our sites, and deployed in version form. We want to thank our colleagues Nadine, Daniel, and Hoshi for the collaboration, and InterSystems for long and fruitful cooperation. And I especially want to thank Michael for the last 18 years of helping me and helping us. He was always there when we needed him. Thank you, Michael.
Thanks, Ralf and Marko, and thanks for the credits. This is very impressive and a good example how container technology and InterSystems Iris containers can help to deal with complex development and deployment environments. So, Q&A. Do you have any questions? Yes, there's a question. There's another question. There's more one?
Yeah. Question. So, you use the containers in production, right?
In production for development at this time, not at the customers. It will follow in, I would say, 1.5 years.
Mm-hmm. So the second question is regarding when you deploy only classes in the container, okay, or not?
No, when we go to deploy the containers, we deploy the images coming from the registry. So our customer systems pull out the image from the registry, start the container.
Yeah, but they have only new classes or change in the code, right?
Yes, but not on our customer systems.
No, okay.
While developing the changes.
But for QD. What about the data? I mean, another mess is you have a pool of data that you want to test in order to, to do something. And if the model is changed, you need to change the data. So do you have any solution for that, or how do you deal with that?
At the moment we decided if we change the data model, we will do this as we did it in the past. It will always go forward. We cannot roll back the data because then we have to do difficult things. Maybe the iris stats, save them, rename them. Although that's not our intention. Mm-hmm. We say if we going from release 230 to 240, and we have to change some data, maybe the subscription, the primary key or so, then migration will be done, but only forwarding.
Mm-hmm. So the data is always compatible with the versions. Okay.
Yeah.
Thank you.
Yeah. Other questions?
How do you deal with data, or could you go a little bit more detail into how you deal with the need of upgrading the data? For example, um, your date times not being in UTC, and then having a 30-year-old database where you've got 8 terabytes of data, and then trying to convert to UTC and timestamps, or did you? That's one example that we're having an issue with.
If I understand right,
the downtime needed to do the conversion, and the customer saying that we will not give you the downtime. So
that was a problem that we have at this time too. It comes a time when we say, yes, we have a new release. Do you want to change this release? And the customer has to say, yes, now I have the time to change. We have machines in the data center with many pharmacies on one server, so they have to decide when is the point to change the release. That they have to try this decision.
So the customer is not always right?
We are in the pharmacy market, and maybe we have 4 pharmacies on one server, and we have weekend. 4 go to sleep on weekend and make a vacancy, and one pharmacy of all these have 24 hours, yes, and then you cannot change the release whenever you want. So this has to be communicated when we change the release. And for the data, the data isn't running in container. The data is by volume mapping out of the container on the Linux machine. So this cannot change in this time. This will always be persistent as it like it was yet. Does this answer your question?
Yeah.
Yes. Okay. Thank you. we can speak later. I can deep it out if you want. Yes. Yeah.
Okay. Well, my question seems to be very related to the same questions before. It's also about data. In my example, it would be, for instance, if your new version, the one that you're developing right now, it has, for instance, I'm just making it up, you need to upload into the database the postcodes of a specific region which is new. Now imagine that you extend the business into a different country and you need to upload the whole postcode databases. Will that be part of the update? How will you solve that? Because that's a different, separated kind of thing, I guess.
But the postcode is for every pharmacy the same, right?
Yes.
Yes.
So it's static data.
Absolutely, yeah.
So the static data can be part of the container, right?
Static data, it can be part of the release.
And it's part of the container today?
Yes.
Yeah. I understand that, but if the database, let's say that you have a postcode class, a data class, right? So you already have some data in your container or in your data container. I don't know where you store the data itself, but it will have some data. So in your update, you will need to add some data to the same class.
Yeah, but if only the static data is part of the container, you can simply update the static data in your image.
The customer data.
The customer doesn't change.
The customer data, so the data of the customer has his customers, has his articles, his own articles, has his wholesalers. This database isn't a part of the container. This database is a part of the volume, and by volume mapping, it's mapped and mounted as database in the container.
Correct.
It's outside of the container.
Correct, but if part of the update precisely is updating this data.
Yes, okay, yeah.
You understand what I mean? Like, for instance, you create a new code table for whatever the reason. In this case, it's postcodes or whatever. But if it's part of the update, because it's part of something that you need to update the system with, how do you solve it?
Yes, it's a nice question. We have one class that we always deployed for very special container. Also for container 240, we have a class named version 240, and there we have methods that we start by, you know, the percent set start make. It's called when the system starts.
Okay.
And when the system starts in the percent set start make, we call this class, this version class, that's the update method. And this update method calls update internal before, when I want to kill some global, for example. Then makes the update, and then it calls method update after. So the developers, when they want to change some data, or build indices or whatever, do this in this version class. And that is run by by %set start method.
I see. Congrats anyway.
Does this answer your question?
Yes, absolutely.
Okay. Stefan, you had a question?
Brief one. So Marko mentioned that when a developer is pushing out changes, so it goes to the TFS, goes to Git, and then you do a pull request to basically reject or accept the change, right? So is this the way of doing your peer review? So you're using the pull request to implement peer reviewing?
Yes, of course. The developer does his work, then not merging the code on this repository, but pushing the branch. Then he takes, states a pull request, and the pull request says, we have to look at other commit messages. Okay, are 3 reviewers are mentioned, and at minimum 1 have to agree and to accept the code. And when they accept the code, then the REST call comes and the machine will take the code. And if we have some problems by compiling or so, then the TFS gets a message back, something not in order. We have errors by compiling or so. Then he gives a mail to the developer and says, hey, your code is not okay. We will not merge them into the branch. Pull request is cancelled. The classes on the build machine were rolled back. So classes which are not ready to deploy will not go to the image. Thank you.
One more question. Last question for this session. We will be here for the rest of the conference, so if you have further questions, reach out to them.
Yeah, a very impressive presentation, thank you. I think when you talked about the pharmacies, 4 pharmacies sharing one machine, is that 4 namespaces in one InterSystems Iris instance that you are saying we have to upgrade, or is it one Linux machine with 4 Iris instances?
At this time, it's one Linux machine, and all the code, we have 4 databases with code or routines. This is guilty for all the pharmacies which running on this system. They have their own data, but they have the same code. So the code containers we have only to update once.
Right, but are they running in 4 Iris instances, or are they running one Iris instance, 4 namespaces?
Yes, we have one Iris system, yeah.
Okay, so if you have further questions, Marko and Ralf will be around until the end of the conference. Reach out to them, either via the event app or via email, and I'm sure they are happy to help you. If you want to learn more,
Yes. Oh, it's stopped.
There are a couple of related sessions here.
It's stopped.
There are a couple of related sessions for containers and DevOps. And as always, we are always interested in improving our content, improving our sessions. Please take the time, go to the event app, provide us our feedback, and let us know what you think. Okay, thank you again. Thank you again, Ralf and Marko, and thank you.